welcome to Vodcast 3.5. Our previous Vodcast was about stream erosion, and in this Vodcast, we kind of look at the flip side of that coin, and that's stream deposition. I want to start off by providing a definition for deposition. Deposition is the geological process in which sediments, soil, and rocks are added to a landform or a land mass. Streams transport sediment, and then they deposit it downstream as the velocity of the stream decreases. I want to revisit a picture that we looked at in the previous podcast. Shown is a meandering river. In the straight sections of the river, the maximum velocity of the water occurs in the center of the stream. And then whenever the river curves, the maximum velocity of the stream will occur at the outer edge of the curve. But let's take a look at the inside of the curve. The slowest river speeds will occur at the inside portion of the curve. And where the river flows slowly, deposition can occur, because when water slows down, the suspended sediment will sink to the bottom because slower water isn't capable of carrying it. A great example of depositional features in streams are deltas. Deltas will form where streams enter still bodies of water. For example, if a river flows into, say, the Gulf of Mexico, the stream velocity will almost grind to a halt where the river meets the Gulf. And when that water slows down, there will be a significant amount of deposition occurring. Let's take a look at an example of a very prominent delta, and that's the Mississippi River Delta. Over a time span of 6,000 years, the Mississippi River has built 7 coalescing subdeltas. Number 7 shown in this picture is the most recent delta, and it formed about a few hundred years ago. And number 1 represents the earliest delta. This picture provides evidence that the Mississippi River, through deposition, has helped build and extend the state of Louisiana out into the Gulf of Mexico. A lot of the land area you see in this picture is the result of deposition. Another important depositional feature are natural levees. When you have a nice wide, well-developed floodplain, where you'll often find meandering rivers, natural levees can form after successive floodings. To understand the formation of natural levees, let's take a look at the picture at the far right of this slide. Let's suppose there's a really heavy rainstorm, causing the river shown at the top to flood. As the river floods out over its natural channel, the velocity of the overflow water will decrease. Now the coarse sediments shown in this image are the larger, heavier pieces of sediment. And when that overflow velocity slows down, the coarse sediments will be the first to be deposited. And they'll be deposited fairly close to the original river channel. The finer sediments, those smaller and lighter pieces, will be carried further away from the original river channel. And as this image shows, to each side of the natural channel, there's a very slight slope, where the larger coarse sediments sit at the top of the slope, very near the original channel, and then from there, there's a downhill slope away from the original channel. Shown in the picture below is a post-flood view, where the natural levees have been built up, very near the original river channel. The third picture from the top shows another flooding, and just as before, the larger, heavier coarse sediments will settle out near the original river channel, and the finer, smaller sediments will be carried much further away from the original river channel. And over time, these natural levees can be built higher and higher and higher, and they can serve as a confining wall for the river. When natural levees form, you might see the formation of what are called back swamps. The natural levees will function as a barrier that prevents water from flowing back into the original river. So back swamps can form in the floodplains where drainage has now become poor due to the natural levees. You can almost imagine those back swamps as sitting kind of in a bowl, where the natural levee serves as the left side of the bowl, and then the valley wall serves as the other side of the bowl. The water will tend to pool in those lower regions of the bowl, and that's where you get back swamps. Yazoo tributaries will run parallel to the river, and they'll do so until they can breach the levee. Just as when you merge onto the interstate, your merge lane runs somewhat close by and parallel to the lanes of the interstate, but eventually you ease your way onto the interstate. A Yazoo tributary will run nearby the meandering river shown, and as soon as there's an area that allows the Yazoo tributary to join back up with the river, it will do so. This last slide is a review for quizzes and tests, because this image shown will pop up multiple times on future assessments. Shown as a meandering river, and at one of the bends in the river, you see 4 sections labeled A, B, C, and D. Pause the video at this point and try to answer the 4 questions shown on the left. When you think you know the answers, go ahead and hit play, and I will overview the correct answers for all the questions. Okay, let's look at the first question. Where is the stream velocity fastest? Whenever we're looking at a meander, which is a curving portion of a river, the fastest velocity will always occur towards the outside of the meander. And letter A is at the outside portion of this curve. So the correct answer for the first question is A. For the next question, where is maximal deposition occurring? Deposition will occur at the region with the slowest velocity. And if the fastest velocity occurs to the outside of the curve, the slowest velocity will occur to the inside of the curve. You will be most likely to see deposition at section D in this image. The third question asks, where is the stream velocity slowest? Well, in alignment with the previous question, deposition occurs where the river is the slowest, and that answer will also be letter D. And then for the final question, where is maximal erosion occurring? Maximal erosion will occur where the stream velocity is the fastest, and the stream velocity will always be fastest at the outside edge of a meander. So maximal erosion would be occurring at the section labeled A. If you have any questions about this slide, please feel free to ask in class, but I can assure you that this picture will be seen again. So hopefully the concepts of erosion and deposition are a little more clear after the previous two vodcasts. That concludes this presentation. In our final vodcast for Chapter 3, we will focus primarily on groundwater.